In this KORNCAST, we're going to take polynomial division to the next step, and we call this synthetic division. If you recall polynomial division, this is the process that we went through. We always got opposites right here. So pretty much if we did everything right up here, this would always happen. So really what we ended up concentrating on were these second terms right here, which came from this -3 right here. Now 2x squared times -3 is -6x squared, and we subtracted it, changed the sign. Same thing here, we got a positive 9x, and we changed the sign. And we got a -15, and we changed the sign. So really one thing that we can do to this is that if we change the sign here to a +3, and we take 2x squared times +3, we get our +6x right now. Same thing, we get our -9x, and same thing here, we get our 15. So one of the things that has to happen with synthetic division is that we need to take this x minus 3, set it equals 0, and solve for x. And we end up getting our x is equal to a 3, if you will, positive. So this part is kind of important. Now again, what we ended up with right here is the goal of this was to get this number right here, get the opposite. Get this number right here, get the opposite. Start with this number right here, get the opposite. So the key is to get these opposites right here. And then we multiply this value, and we ended up getting these values right here. So this is the synthetic division process. What we did is we took this x minus 3 and we changed it to a +3. And the best thing to do, I think, is to set it equal to 0 and solve for this. Because sometimes if this coefficient right here is not a 1, things get a little sticky. Now, to get these values right here, did we really worry about the x squared? We did when we multiplied x times this, but what we were really concerned about were the numbers themselves. So let's just take the coefficients here. A 2, a -9, a 14, and a -8. And what we ended up having right here is a process where we had this -2x and it eliminated right here. But we took this 2 times -3 and got this 6 right here. So what we end up right here is that if we bring down this 2 right here and put it down below this line right here, we take 3 times 2 and gives us our 6, which is the same number we got right here. And then what do? Well, we added them to get -3x squared. So we add them and we get -3. And then what do we do to get this -9x right here? Well, can't we take -3 times 3 and get -9? And there's our 14x minus 9x right there. So 14 minus 9 gives us our 5. And then how do we get this 15? Well, we took 5 times 3 and gave us our 15. So 3 times 5 and we get 15. Then how do we get 7? Well, we added them and got a 7 right there. So let's take a look at what we got right here. We got a 7, which is our remainder. Well, guess what? 7, which is our remainder. So what we end up with right here is our process. Here's our constant term. Here's our x column, and here's our x squared column. So again, the columns have everything to do with this. And let's look at what we have here. We have a 2 and a 2, a -3 and a -3, and a 5 and a 5. So these end up being the coefficients of our quotients. Okay? So we end up with, if we look at this, we end up with 2x squared minus 3x plus 5 plus 7 with our remainder divided by what we divided by. So this process right here of synthetic division is a nice, quick, and simple way of dividing without having to do this long division process. Again, we're dealing with the coefficients, so we're doing the same process we did right here, but we're just dealing with the numbers themselves. So we can look at this right now and notice that this is going to give us 2x squared minus 3x plus 5 plus our remainder divided by what we're dividing by. So let's look at a couple more examples, and hopefully this will be a little bit clearer. But the reason why I did this is I just wanted you to know that it wasn't just magic. There's the actual process that happened here. We're doing the exact same things, except we're not worrying about our terms. We're just dealing with the coefficients. Alright, so setting this equal to 0 gives us a -2. So that's going to be in our synthetic part right here. We have a coefficient of a 1, coefficient of a 5, and notice there's no x squared term here. So this would really be plus 0 times x squared. I wrote 2x. Come on, Preskorn. Alright, so this is x squared. So I'm going to put a 0 in for that. Minus 9 plus 6. Draw my line down here. Now again, the first step is as follows. You're going to take the first term and bring it down. 1. Always, always, always. Then just multiply. -2 times 1 is -2. And add 3. Same thing. -2 times 3 is -6. And add. -2 times -6 is 12. And add. And last but not least, -2 times 3 is -6. And add. And again, this last term is always going to be a remainder. And right now, we have a remainder of 0, so put on your happy face. This is nice. This divided by this gave us that. So what does it give us? Well, since this is our remainder right here, this is our constant term, our x squared, x cubed. So our answer is going to be x cubed plus 3x squared minus 6x plus 3. And that's our answer. So this divided by this gives us that. Alright. That's nice. That was so much easier than doing that long division process. So much easier. So it's a nice little quick way of doing things. Alright. Now, why divide? What's its purpose? It's not just mere torture to help us through life here. It actually has a purpose. So if you recall, this divided by this from the previous example is this. And from our synthetic division or long division process, depending on which one you want to use, gives us this. Well, let's go ahead and do this. Let's make a proportion out of this. Fraction equal to a fraction. How do we solve? Well, we can do our cross multiplication process. So 4x squared plus 5x minus 9x plus 6 times 1 is just that. Is equal to, well, x plus 2 times quantity x cubed plus 3x squared minus 6x plus 3. Now take a real close look at your answer right here. What did we just do here? We just factored. So what is division good for? It's good for factoring large degree polynomials. Pretty neat. Right, there's synthetic division. Now, do you have to do synthetic division? No, you can do long division. Nothing wrong with that. But I think synthetic division makes life easy.